Okay, today we are starting with carbon and its compounds. That is the final chapter of chemistry in class 8. There are some important things to be noted in this particular part, very important. Carbon is considered third most important elements after oxygen and hydrogen for the existence of life on Earth, because every other compound is made up of carbon. As a matter of fact, elements hydrogen, oxygen, carbon and nitrogen are called organogens, which means the substance from which organic life, that is plants, animals, started. So this is the basic building block of our life. Carbon constitutes only 0.03% of Earth's crust, yet it forms innumerable number of complex compounds with hydrogen, oxygen, nitrogen. Over 400,000 compounds of carbon have been known till now. Most of these compounds are produced by plants and animals naturally. However, some of the compounds of carbon are prepared by chemists artificially. For fuel, clothing, food, herbal medicines, we have to depend entirely on carbon compounds. Vast amount of energy is needed to run factories, that is also obtained by carbon compounds such as coal, petroleum and their products. That is fuels. So fuels are also carbon compounds. In fact, there is no walk of life where carbon compounds are not used. Carbon compounds are there everywhere. You are sitting in a room, look around you. Everything around you is made up of some or the other kind of carbon compound. Let that be the desk on which you are sitting, which may be made up of wood. Wood is a carbon compound. The paint on the wall is a carbon compound. The plastic objects around you made up of carbon compounds. Rubber made up of carbon compounds. Clothes made up of carbon compounds. Everything around you must have carbon in it. So study of carbon and its compounds becomes inevitable in chemistry. We have to study them separately. In fact, in chemistry, there is a branch of dedicated to the study of carbon compounds. Suppose we can say that chemistry is a study of elements and compounds. Then it can be divided into two major branches. One is inorganic chemistry, and the other one is organic chemistry. Inorganic chemistry is related to the study of compounds of all the other elements except carbon. There are total 118 elements known till date in the periodic table. Out of 118 elements, 117 elements are studied with their compounds. They are studied in inorganic chemistry. Only one element, that is carbon, is studied separately because it has more than 50 million compounds. 50 million plus compounds it has, only carbon. So only carbon compounds are amounting to much more number as compared to all the other elements combined together. The compounds of all the elements combined together are way less than only the carbon compounds. Okay? So that's why the study of carbon and its compounds has to be done very precisely, meticulously and separately. They should not be merged with the rest of the elements, because carbon has a capability of forming huge number of compounds, and to study their properties we have to make a separate branch for studying carbon and its compounds. So let us start this chapter with the free states of carbon. There are three major free states of carbon: diamond, graphite and coal. Diamond and graphite, they both are considered to be the purest state of carbon, purest form of carbon, out of which diamond is the most pure. Graphite is somewhat pure, little less pure. But coal is an impure form of carbon, in which carbon can be between 60 to 90%. Yeah, if you do destructive distillation of coal, then you can get coke. Coke is not, I'm not talking about Coca-Cola, Coke. I'm talking about the purest form of coal, which is coke, which is black in color, which is 99% pure carbon. So these are the free states in which carbon occur. In combined state, carbon can occur in solid, liquid or gaseous, any state. In nature, all the all the animals and plants products in solid states are carbon compounds, such as cellulose, the fruits you eat, vegetables basically, the leaves, the fruits, the seeds, the nuts, the roots, everything, they are all carbon compounds. Carbohydrates, fats and proteins, which are the major components of your diet, also carbon compounds. And carbon also occurs in mineral salts in the form of carbonates. You might have heard of marble, which is also known as limestone. That is a carbon compound, calcium carbonate. Magnesium carbonate, calcium and magnesium carbonate together combined as dolomite. Calamine, which is zinc carbonate. These are all the carbonates of or compounds of carbon. Then in liquid state, petroleum is an example in which carbon is found in liquid state, which consists of petrol, kerosene, diesel, furnace oil, mobile oil, grease, wax. In addition to that, vegetable oil. Vegetable oil means you can say your oil which is used for cooking. That also has carbon in it. In gaseous state, air contains a lot of carbon, carbon dioxide, methane, petroleum gas, coal gas, they all have carbon. So carbon not only occurs in solid state but also in liquid and gaseous state, not only in free form but also in combined form around you. Now, there is one new term which you have to study in this chapter, which is known as allotropes. What are allotropes? See, I have written the definition of allotropes here. Allotropes are same elements, atoms of the same elements, or you can say form of the same elements, having same chemical properties but different physical structures or properties. Okay, atoms having same chemical properties but different physical structures are known as allotropes of an element. So carbon is known to have allotropes. So it has been found that carbon is found in two forms, two states, two allotropical forms, which is diamond and graphite. I just talked about that little while ago. Okay. So diamond and graphite, apart from diamond and graphite, there is coke and charcoal also, but we will focus on diamond and graphite only. So यहाँ पे allotropes या allotropic forms की definition दी है नीचे, जरा ध्यान से देखो. Various physical forms of an element having different physical properties but same chemical properties are called allotropic forms or allotropes. Elements के जो अलग अलग form होते हैं, जिनकी फिजिकल प्रॉपर्टीज अलग अलग होती है बट केमिकल प्रॉपर्टी सेम होती है, उनको हम एलोट्रोपिक फॉर्म बोलते हैं या एलोट्रोप्स बोलते हैं. ठीक है, तो जैसे डायमंड और ग्रेफाइट एक दूसरे से कितने अलग हैं. डायमंड इज द हार्डेस्ट नेचुरली अकरिंग सब्सटेंस, वेरी शाइनी, राइट, एंड इट हैज अ वेरी हाई मेल्टिंग एंड बॉइलिंग पॉइंट, very high density. Graphite on the other hand is not hard, it is brittle. जो तुम्हारे पेंसिल का अंदर का लेड होता है वो ग्रेफाइट का होता है, टूटता है ना इजीली, ज्यादा शार्पन कर लो तभी भी टूट जाता है. तो कितना इजीली टूट रहा है, ठीक है, थोड़ा प्रेशर दे दोगे तो टूट जाएगा. सो दैट इज नॉट वेरी हार्ड बट इट इज स्टिल कार्बन. डायमंड इज वेरी हार्ड बट स्टिल कार्बन. Both have different physical properties, but both are carbons. That's why both are known as allotropes of carbon. Allotrope word याद रखना. So allotropy is the phenomena due to which elements exhibit different physical forms which have same chemical properties. So the two main allotropic forms of carbon are crystalline form and amorphous form. Crystalline form किसको बोलते हैं? क्रिस्टलाइन फॉर्म में जो ज्योमेट्रिक शेप्स होते हैं, जब ये टूट जाता है कोई भी एलिमेंट, तो ये प्रॉपर स्ट्रेट लाइंस और ऐसे ज्योमेट्रिक शेप में बनते हैं, क्रिस्टल जैसे बनते हैं. when we know that carbon has that geometric form, that crystalline form, and amorphous does not have definite shape. When we cut or when we break this, they don't have any sharp edges or anything. ठीक है, so they don't have a definite melting point also. यहाँ पे कुछ फॉर्म्स को डिवाइड करके दिखाया है. इट्स रियली इंटरेस्टिंग टू नो दिस, दैट कार्बन के दो फॉर्म्स है, क्रिस्टलाइन और एमॉर्फस. क्रिस्टलाइन फॉर्म में डायमंड और ग्रेफाइट आता है, और एक तीसरा फॉर्म आता है फुलरनेस. फुलरनेस हम लोग पढ़ेंगे इस चैप्टर में. एमॉर्फस फॉर्म में कार्बन एग्जिस्ट करता है इन द फॉर्म ऑफ चारकोल, लैम्प ब्लैक, कोक, गैस कार्बन. और चारकोल के भी तीन टाइप होते हैं, वुड चारकोल, बोन चारकोल, शुगर चारकोल. वुड चारकोल, एज यू नो, वुड जब बर्न करते हैं ना, जो एशेस बचती है वो वुड चारकोल बनता है उससे. बोन चारकोल ऑल्सो यू हैव गेस्ड राइट इफ यू हैव दैट, जब कोई भी एनिमल या फिर ह्यूमन की बॉडी को बर्न करते हैं तो उसके जो बोन्स होते हैं उसमें से बनता है बोन चारकोल. एंड शुगर चारकोल इज व्हेन the molasses, that is शुगर केन जूस को जब हम लोग हीट करते हैं और जो एंड में जो गाढ़ा और डार्क कलर का लिक्विड बच जाता है उससे शुगर चारकोल बनाते हैं. दे ऑल आर द फॉर्म्स ऑफ चारकोल. सो amorphous फॉर्म में there is no definite shape and structure, but crystalline form has a definite shape and structure. Let us study about the first crystalline shape, that is diamond. So India में diamonds are found in the mines of Panna in Madhya Pradesh and the mines of Golconda in Telangana. Diamonds are also found in South Africa, Brazil, Russia and United States of America. There are diamond mines. Basically they used to be coal mines, but then by mistake or by chance somebody found a piece of diamond in the coal mines, and they kept on finding more such pieces of diamond, and hence the coal mine was then converted into diamond mine. And don't underestimate or overestimate diamond. Diamond can be cheap also and it can be expensive also. It can be cheap when it does not have that specific form or structure, when it is not having that property of giving a proper shape like diamond, then it is very cheap. Some diamonds are very cheap because they are not having that kind of structure. So what they do is, when they get the diamond, they cut it and they polish it and they give it a proper structure and shape, and then they make it more and more you can say expensive or more and more worthy. All the diamonds are not originally such. Diamond is like a rock, like a stone. When it is polished and cut and given a proper structure, then it becomes expensive. Okay, the diamonds which are not expensive, they are used for other purposes. जैसे diamond is the hardest naturally occurring substance known, so diamonds are also used in the tools. जैसे ड्रिलिंग मशीन होती है, ड्रिलिंग मशीन के टिप पे डायमंड अटैच करते हैं तो उससे कोई भी मेटल के अंदर ड्रिल हो सकता है. डायमंड कटर्स भी आते हैं. ग्लास के अगर शॉप में तुम गए हो, ग्लास होते हैं ना, विंडो ग्लास या फिर मिरर, थिक मिरर या थिक ग्लासेस जो होते हैं उनको कट करने के लिए डायमंड कटर होता है. सो डायमंड कटर से एक लाइन ड्रॉ करते हैं एंड व्हेन दे मूव इट लिटिल बिट इट गेट्स कट लाइक इन अ प्रॉपर लाइन. सो डायमंड कटर्स आर वेरी यूजफुल. सो चीप डायमंड्स उसमें यूज होते हैं, सिंथेटिक डायमंड्स भी होते हैं, वो भी यूज कर सकते हैं. सो यहाँ पे पूरा प्रोसेस बताया है हाउ डायमंड्स आर फाउंड इन नेचर. बहुत इंटरेस्टिंग है ये. द अर्थ कंटेन्स मोल्टन मैग्मा. Sometimes carbon present within the earth dissolves in this molten magma. When this molten magma containing dissolved carbon is pushed up towards the surface of the earth, it solidifies. The iron present in the magma on solidification expands and exerts a great pressure on carbon. So molten magma में बहुत सारे एलिमेंट्स प्रेजेंट होते हैं, उसमें से आयन और कार्बन मेन है. तो जब मोल्टन मैग्मा के अंदर जो कार्बन डिसॉल्व होता है, उसको जब अर्थ के सरफेस पे वो आता है, वो सॉलिडिफाइड हो जाता है. और आयन ग्रेट प्रेशर एक्सर्ट करता है कार्बन के ऊपर सॉलिडिफिकेशन होने पे, और फिर कार्बन क्रिस्टलाइज होके डायमंड की फॉर्म में कन्वर्ट हो जाता है. So this fact is supported by the discovery of diamonds in the shaft of extinct volcanoes. पुराने extinct volcanoes के shaft में diamond मिले. So that is the proof कि diamond कैसे बने. ठीक है, देखो structure देखो diamond का कैसा होता है. A diamond crystal has usually 8 sides forming double pyramids. In a regular diamond crystal, each carbon atom is held firmly in place by 4 bonds of neighboring carbon atoms. Such a configuration forms highly strong bonds and hence makes it hardest naturally occurring substance. तो क्या होता है डायमंड में, कुछ स्ट्रक्चर ऐसा होता है. सपोज एक कार्बन का एटम है, इट इज कनेक्टेड विथ 4 अदर कार्बन एटम्स, यहाँ पे, यहाँ पे, यहाँ पे, यहाँ. ठीक है, तो ये एक कार्बन ये चारों के साथ कनेक्ट हो गया. कैसा शेप बना दिख रहा है तुम्हें, एक पिरामिड जैसा शेप बना, इसको बोलते हैं टेट्राहेड्रॉन. अच्छा, फर्दर इस शेप को आगे बढ़ाते हुए ये वाला जो डायमंड है वो भी फर्दर 4 कार्बन से कनेक्टेड होगा, और ये वाला कार्बन भी 4 कार्बन से कनेक्टेड होगा. सो सारे कार्बन के एटम्स 4 कार्बन के एटम से कनेक्ट होके ऐसा एक शेप बनाते हैं जिसको हम लोग बोलते हैं टेट्राहेड्रॉन शेप. ठीक है, सो ऐसे स्ट्रक्चर जो रेडी होता है वो डायमंड का स्ट्रक्चर होता है बेसिकली. सो डायमंड इज वेरी स्ट्रॉन्ग बिकॉज ऑफ दिस स्ट्रक्चर टेट्राहेड्रॉन. द नेम इज टेट्रा. टेट्रा मीन्स 4, हेड्रॉन जिसको 4 हेड होते हैं, टेट्राहेड्रॉन. उसको हम पिरामिड भी बोल सकते हैं. ठीक है, सो ऐसे हम लोग डायमंड का स्ट्रक्चर समझ सकते हैं एंड व्हाई इट इज वेरी हार्ड और स्ट्रॉन्ग. यहाँ पे देखो क्या बोला है, डिड यू नो में. आर्टिफिशियल डायमंड्स वर प्रिपेयर्ड बाय अ फ्रेंच केमिस्ट Moissan in 1886. He melted a mixture of sugar, charcoal and iron in an electric furnace till the temperature of 4000 degrees Celsius. At this temperature, the iron boiled and dissolved sugar, charcoal in itself. He poured the boiling mixture in cold water to form a solid mass of iron and carbon. He removed iron from this mass by dissolving it in hydrochloric acid. On removal of iron, the residual carbon contained tiny diamonds, which is artificially made, cheap, not very expensive. Value of diamond. The value of diamond depends upon number 1, its weight, and number 2, freedom from flaws and impurities. कभी कभी डायमंड में फ्लॉज भी होते हैं, क्रैक्स होती है, इम्प्यूरिटी होती है, पैचेस होते हैं अंदर, तो उसकी कोई वैल्यू नहीं होती. The weight of diamond is expressed in carats, where 1 carat is 0.2 gram. Following are the some world famous diamonds mined from Golconda in Telangana. Kohinoor's original weight was 186 carat, but it was later cut to 106 carats. Pitt, which weighed 136.02, 136.25 carats, and Nizam, which weighs 277 carats. फिजिकल प्रॉपर्टीज ऑफ डायमंड. ये देखो डायमंड का स्ट्रक्चर जो मैं बता रहा था, टेट्राहेड्रॉन, समथिंग लाइक दिस. So it is the hardest naturally occurring solid. Amongst the diamond, black diamonds are the hardest. Pure diamond is colorless, transparent and brittle solid. A pure diamond is transparent to X-rays and visible light. The density of pure diamond is 3.5 gram per centimeter cube. Very high density. Not as high as iron, but yeah, very high. It is poor conductor of heat and electricity. Its refractive index is 2.5. So due to the high refractive index, it sparkles a lot. The rays of light actually they deviate a lot and then they get totally internally reflected within the diamond and it sparkles. It feels like light is coming out of the diamond. So it has that brilliant brilliance, you can say. It is insoluble in all solvents. It is stable towards heat. If diamond is heated in vacuum, it does not melt. However, prolonged heating will change it to graphite. Diamond and gems, colored diamonds except black diamond, sparkle brilliantly when properly cut and polished. They are used for making ornaments. Hard material. Black diamonds in general are imperfect. The badly colored diamonds have little use as precious stones. However, due to their extreme hardness, they find use in industry for cutting glass as well as cutting other diamonds, as tip of deep boring drills, as bearings in watches, as tips of tools for cutting very hard metals. Diamond dust is used for polishing diamonds. Diamonds are used as needles for long playing record players, and so on. The colorless and transparent diamonds are the costliest. However, if there are specks of impurities, their value decreases. Sometimes, while crystallizing in nature, small traces of metallic oxides get dissolved in diamonds, which impart them distinct color. The colored diamonds are called gems. तुमने सुना होगा gems के बारे में. एक ग्रीन कलर का जेम होता है, डायमंड होता है, बेसिकली उसको बोलते हैं एमराल्ड. We have topaz, rubies. Ruby red होता है, and topaz is I think I don't know the color of topaz is yellow or something, orange, yellow.
I guess.
However, if copper oxide is present in diamond, its color changes to black, and the black diamonds have no gem value, but they can be put to industrial use. Okay, so this was all about diamond. Now graphite. Vast amounts of graphite occur naturally in Sri Lanka and Siberia. Some deposits are also found in Italy, Canada, Madagascar, Mexico, United States of America, and so on. Graphite is prepared artificially by heating powdered coke mixed with little sand and ferric oxide in an electric furnace. Structure of graphite. In graphite, the carbon atoms are arranged in the form of hexagonal rings in flat planes. ग्रेफाइट का स्ट्रक्चर दिखा है, मैं यहाँ पे बताता हूँ. ये देखो, दिख रहा है ग्रेफाइट का स्ट्रक्चर. हेक्सागोनल रिंग्स है ऐसे फ्लैट प्लेन्स में. तो एक प्लेन है हेक्सागोनल रिंग्स का, फिर और एक प्लेन है हेक्सागोनल रिंग्स का. इसमें अगर तुम देखोगे ना, तो एंड्स में जो कार्बन के एटम्स है, ये वाला एटम या ये वाला एटम, ये वाला एटम, वो किसी से कनेक्टेड नहीं है. सो कुछ एटम जो किसी से कनेक्टेड नहीं होते हैं, दे हैव देयर 1 इलेक्ट्रॉन फ्री और 4 इलेक्ट्रॉन्स फ्री. सो दैट मीन्स ये जो फ्री इलेक्ट्रॉन्स है, ये इलेक्ट्रिसिटी कंडक्ट करने का काम करते हैं. सो दैट्स व्हाई ग्रेफाइट इज अ गुड कंडक्टर ऑफ इलेक्ट्रिसिटी. ठीक है. सो हेक्सागोनल रिंग्स होती है, फ्लैट प्लेन्स, मैंने दिखाया स्ट्रक्चर, सच दैट द रिंग्स आर स्टैक्ड वन ऑन अनदर. Each carbon atom in the hexagonal ring is attached to 3 carbon atoms in the same plane. Diamond में क्या था? Each carbon atom was connected to 4 carbon atoms, and they were not in a ring or a plane. They were connected like a pyramid. Here they are connected in the form of hexagonal rings. So each carbon atom is connected to 3 other carbon atoms. Okay. The fourth valence electron of each carbon atom remains loose between the hexagonal planes. This loose fourth electron of each carbon atom imparts properties of heat and electrical conductivity to graphite. Furthermore, loose bonds between hexagonal crystals enable them to slide. This makes graphite smooth, slippery, and excellent lubricant. Physical properties of graphite. It is a dark gray solid having a metallic luster. It is soft, it has a soft, greasy touch. It makes the paper gray, not black. Pencil से paper gray बनता है, black नहीं बनता है. Its density is high, 2.25 gram per centimeter cube. It is a good conductor of heat and electricity, and it is insoluble in ordinary solvent. Uses देखो, pencil lead, graphite mixed with clay or finely powdered sand. It is then molded to form thin rods which are called pencil lead. The hardness of pencil lead depends upon the amount of clay in it. The more clay, harder the pencil lead is. तुमने ये देखा होगा कि पेंसिल के ऊपर ऐसे कोड्स होते हैं, HB, 2B, B, H, 2H. इसका मतलब क्या है? B का मतलब होता है ब्लैक, H का मतलब होता है हार्ड. B, 2B means more black, more graphite, less sand. 3B, 4B, 10B तक आता है, 12B तक, आई डोंट नो. बहुत डार्क पेंसिल्स भी आती हैं जिसमें ज्यादा से ज्यादा ग्रेफाइट और कम से कम सैंड होती है. ठीक है. और HB, H, 2H, इसमें सैंड ज्यादा होती है, ग्रेफाइट कम होता है, इसलिए वो लाइट होती है, पेंसिल लिखने में बहुत डिफिकल्ट होती है. यूज फॉर ड्राइंग बेसिकली. Electrodes. Graphite is a good conductor of electricity. Moreover, it does not react with acids and alkalis. So it is used for making electrodes for electrolytic cells. जहाँ पे इलेक्ट्रोलिसिस होता है ना, एनोड कैथोड, तुमने सुना होगा. एनोड और कैथोड ग्रेफाइट से भी बनाते हैं. उनका फायदा ये है कि ये इलेक्ट्रिसिटी भी कंडक्ट करते हैं और ये केमिकल्स के साथ रिएक्ट भी नहीं करते हैं. जो तुम्हारी बैटरी होती है, उसमें बैटरी में जो अंदर इलेक्ट्रोड्स होते हैं वो ग्रेफाइट के होते हैं. Dry lubricant. Graphite powder suspended in oil is used as a lubricant in those parts of machinery where oil cannot be applied easily. तो वहां पे ग्रेफाइट का पाउडर यूज होता है, वो lubricant की तरह काम करता है. Heat resistant crucibles. Graphite is mixed with clay and it is molded and baked to form crucibles which are heat resistant. These crucibles can withstand high temperature due to clay and are good conductors of graphite. Good conductors due to graphite. Nuclear reactors. In nuclear reactors, atoms of uranium, thorium, they split to produce neutrons. ये जो process है nuclear reactor का, ये तुम पढ़ोगे higher standards में. Still, if you want to know about what is nuclear reactor and how does it work, there are many videos available on nuclear reactors. I might give you few. तो वो तुम देख के थोड़ा आइडिया ले सकते हो. न्यूक्लियर एनर्जी के बारे में आई थिंक पढ़ा है हमने पहले. आई डोंट रिमेम्बर वेरी वेल बट आई थिंक मैंने बताया था. स्टिल आई विल शेयर विथ यू. सो दीज न्यूट्रॉन्स कैन लीड टू न्यूक्लियर एक्सप्लोजन. To avoid such situation, graphite is used in nuclear reactors, which slows down the excess of neutrons. ठीक है. इसके बाद है Fullereness. Fullereness is a crystalline form of carbon having 30 to 960 atoms in one molecule. One of the member of Fullereness is Buckminster Fullereness. ये जो Buckminster Fullereness है उसका शेप बहुत ही peculiar होता है. It has a football kind of a shape with alternate pentagonal and hexagonal rings. वो black and white football देखा है तुमने? पेंटागन रिंग, हेक्सागन रिंग, पेंटागन रिंग, हेक्सागन रिंग, वैसा शेप रहता है इसका. और इसमें सारी जो रिंग्स के वर्टाइसेस होते हैं वो कार्बन एटम्स होते हैं. तो बकमिंस्टर फुलरेंस क्यों नाम दिया गया है इसको, इसके पीछे का रीजन मैं बताता हूं तुमको. बकमिंस्टर फुलर ये एक अमेरिकन आर्किटेक्ट था, बकमिंस्टर फुलर. और ये कुछ ऐसे स्ट्रक्चर्स बनाता था. देखो ये देखो स्ट्रक्चर, कैसा स्ट्रक्चर, ऐसा रियल में ओरिजिनल ऐसे स्ट्रक्चर्स बनाता था अलग अलग जगह पे, मॉन्यूमेंट्स में. और उसका जो स्ट्रक्चर था दैट वाज दो स्ट्रक्चर्स resembled in their shape and size and in their feel with this molecule, with this allotrope of carbon. इसलिए उसको बकमिंस्टर फुलरीन नाम दिया. एक्चुअली इसका नाम फुलरीन है. बकमिंस्टर फुलरीन या फुलरिनस इसलिए नाम दिया बिकॉज वो आर्किटेक्ट के स्ट्रक्चर्स के साथ इसका शेप मैच करता था. So it also occurs naturally in dust between the stars and some carbon-rich rocks. In Buckminster Fullerene, each molecule has 60 atoms arranged in hexagonal and pentagonal rings. The double covalent bonds join hexagons and pentagons. Buckminster Fullerene is a bad conductor of electricity, but some forms of Fullerene family are superconductors, that is, they do not offer any resistance to electric current. Fullerene were discovered by H. W. Kroto, R. F. Curl and R. E. Smalley in 1985, for which they were awarded Nobel Prize in 1996. इसका uses क्या है अभी तक पता नहीं है. Scientists are still trying to find out कि ये जो allotrope है इसके क्या use है. We don't know till now. The actual chemical names of fullerene is spheroidal carbon cage molecule. C60 molecule has been named as Buckminster Fullerene after the name of an American architect, Robert Buckminster Fuller, who designed steel structures similar to those of fullerene molecules जो मैंने अभी तुम्हें दिखाया. ठीक है. So this was the first part of the chapter, more about the introduction. कार्बन क्या है, उसके कौन से स्टेट्स है, कौन से फॉर्म में एग्जिस्ट करता है, उसके एलोट्रोप्स कौन से, उसके यूजेस क्या है, कैसे बनता है, प्रॉपर्टीज क्या है. द होल एक्सरसाइज 9.1 is your homework which is based on whatever I have taught you till now. ठीक है. So this is what we have done. अभी नेक्स्ट क्लास में इससे ही कंटिन्यू करेंगे. इसमें बहुत सारी चीजें हैं. ये बड़ा चैप्टर है, 3 पार्ट है इसमें, काफी सारी चीजें पढ़ेंगे हम लोग इसमें. And this will be the final chapter of chemistry. ठीक है.
Yes. Yes, sir.
Okay, so